Hi everyone, and welcome to my talk. So choosing the right messaging platform can be a challenge. You might be considering alternatives to classics like Kafka and RabbitMQ. And this is why I'll offer insights on selecting the appropriate messaging platform and introduce you to an alternative to the well-known Kafka and RabbitMQ, Apache Pulsar. I'm Julien. I'm developer advocate at StreamNative. You can see a QR code and a link on your screen. Feel free to scan this QR code. That's the best way to reach out to me and to get access to additional resources, for example, case studies and benchmarks. StreamNative was founded by the original creators of Apache Pulsar. We are one of the largest contributors to open source, Apache Pulsar and the ecosystem surrounding it, and we provide a fully managed Pulsar service with enterprise features. This service can be deployed on either our infrastructure or your infrastructure. So what is Apache Pulsar? Apache Pulsar is a cloud-native messaging and data streaming platform. Cloud-native means that Pulsar is designed for running in containerized environments and is designed to scale out, to scale horizontally. But it's not only about scalability, but also about elasticity. Elasticity is about adapting to workload changes, and Pulsar is both a messaging and a data streaming platform, as we will see in this presentation. Pulsar is a messaging and streaming platform, but what is data streaming? Data streaming is a process of transmitting data continuously and in real time from a source to a destination. The data is sent in small pieces and is processed or analyzed as received, right? Streaming works best when this data needs to be processed in the right order. The data, these events, they can be interlinked together. These data may be persisted for a long time, but also transformed, aggregated, or replayed. You may also need to read millions of records very quickly and perform big catch-up reads. So you need throughput. Streaming platforms can handle massive amounts of data, so these platforms scale out horizontally. The typical use cases include data ingestion. That's the process of collecting and importing data from various sources for storage, processing, and analysis. Other use cases can be about real-time analytics. So you will make the right decisions based on fresh data. The most common streaming platform is Kafka. I can also mention Amazon Kinesis, and of course, Pulsar is also a great streaming platform. Now let's talk about messaging. That's very different. Sometimes we need to assign time-consuming tasks to a group of workers. One producer service needs tasks to be performed by a consumer service that is a worker. These tasks can take some time to process, or the consumer service can be unavailable for a couple of minutes. And we don't want these events to impact the producer service. We need decoupling. To do that, you can set up a work queue, and this queue contains then the messages from the producers, and each of these messages is a task to be performed by consumers. You don't need to perform these tasks in a strict order. For example, if the task consists in pushing notification to Alice and Bob's iPhones, it doesn't matter if I notify Alice or Bob first, right? A message broker manages this message queue, accepts the producer messages, and delivers them to the consumers so they can perform the task. So there are some essential features for message queue. Queue can grow faster than consumers can handle. So one expected feature is the ability to add new consumers, to consume the queue faster and remove consumers when the workload decreases. Another expectation is when a consumer is busy processing a message, you don't want to wait for the processing to be completed. The broker will deliver the next task to another consumer instance without waiting for the current task to be completed. When a consumer fails to handle a message because of an error or a timeout, you may need the message broker to redeliver the message later to retry the task. And you also need to remove undeliverable messages from the queue and move them to a dead letter queue. Because of that, messages may then be consumed in a slightly different order than produced. But as we said, the order is not a strong requirement here. So RabbitMQ and Amazon Sequence match these requirements because they implement this message queue semantic, and we cannot expect these requirements from a streaming platform. These platforms are not designed for that. Does it mean you have to choose between messaging and streaming? Or do you have to manage two different platforms, one for messaging and another for data streaming? This is not a dilemma with Pulsar. You can do both using the same platform, the same technology. So you have only one SDK to learn, and you have only one broker to manage in production. So we just saw that Pulsar can handle both messaging and streaming use cases. This is one of the key features of Pulsar. Now I want to talk about Pulsar scalability and elasticity. These are different things. Elasticity means you can grow or shrink resources quickly to adapt to workload changes, so you can save infrastructure cost by avoiding over-provisioning. Some data streaming platforms like Kafka and Pulsar can scale very well, but Pulsar is both scalable and elastic. The scalability requirements are determined by the bottleneck you have to address. If your bottleneck is the number of messages to be consumed in a topic, then you need to scale on the consumer side. But when the bottleneck is the number of topics or the number of connections with clients, then you need to add more processing power to the Pulsar cluster. And when the bottleneck is the storage capacity, then you need to add more storage capacity to the Pulsar cluster. Let's delve into the first bottleneck, which is likely to be the most common one you will encounter. Suppose you have multiple consumers consuming a topic. What happens if the number of messages to be consumed grows faster than the consumers can process them? With Pulsar, you just have to add new consumers to what we call a shared or key share subscription. So you can increase the throughput by adding new consumers. With Kafka, when you need to add a new active consumer to the consumer group, then you need to add a new partition to the topic. For that, you need to perform an operation on the broker side, and you also perform a rebalance of the data across the partitions. This can be heavy and lead to performance loss or even downtime, so you have to anticipate and plan carefully, right? But Pulsar doesn't have this issue. And of course, when you have fewer messages, you may end up with underutilized consumers. You can also remove them to save infrastructure cost. All of that while preserving the ordering guarantee, unlike traditional messaging brokers. Now that we delved into the most common bottleneck, let's explore how Pulsar can handle a rapidly increasing number of consumers and producers. But first, I need to explain the unique architecture of Pulsar. This architecture is more sophisticated than other platforms, so it brings many benefits. In Pulsar, there are two types of nodes, the broker nodes and the bookie nodes. The broker nodes are responsible for managing all the communication and the processing of the topics, so they are stateless. They don't store data. So a broker node deletion won't impact the data. In contrast, the bookie nodes are responsible for storage. They have states. They store the messages. So let's say that I need more processing power on my cluster. I will add more brokers. Because their state is stored in the bookkeeper tier, I can add a new broker, and that load can then be migrated to another broker. So some of the magic of Pulsar is it will take care of all of the moving of the connections, and the moving is transparent to your application. If you compare this to Kafka, then adding a new broker, I will have to manage the movement of all of the data to another broker to rebalance it. There is no heavy partition rebalance here and no data movement. When we need to store more data, then we just add more bookies. As soon as you add a new bookie, it's going to be eligible for getting new messages right away. It immediately becomes functional. There is no data rebalance. Pulsar doesn't have this issue when you need scalability on your data. So here is a recap of the three levels of elasticity and the benefits compared to other streaming platforms. When you do data streaming or messaging, your most bottleneck is the consumer. The advantage of Pulsar is that scaling consumer doesn't require complex operations like adding partitions. If your bottleneck is the processing power on the broker side, you just have to add new broker nodes without the need for data movement across nodes. And finally, if storage capacity is your limiting factor, then adding new booking nodes resolves the issue. And unlike other platforms, these nodes immediately receive new messages. And of course, you can easily downscale to save on infrastructure cost. To ease the use of Pulsar in a Kubernetes environment, StreamNative developed Kubernetes operators. These operators facilitate the deployment of Pulsar cluster on Kubernetes. You can define your desired cluster configuration using familiar Kubernetes manifest files, and this allows for seamless scaling and facilitates the installation of additional components. You can find the documentation on the StreamNative website, and StreamNative offers these operators under a simple and free-to-use community license. So I just presented how you can scale Pulsar with its multi-layered architecture, which is the second key feature of Pulsar. Now let's shift our focus on another critical aspect. How does Pulsar safeguard the durability of your data? Pulsar topics are made of segments, and these segments contain the messages. Pulsar can distribute the segments to separate buckets. This is how a single topic is distributed across several data nodes. It's important to note that this storage model is completely different from the Kafka storage model, which is a partition-based model. Here you have a replication factor of 3, so every segment is replicated on 3 different bookie nodes. So if I kill one bookie, here the bookie 2, I still have all the segments in the other bookies, so I haven't lost any data. You may need to store a big amount of data and retaining for a long time, depending on your use case. You'll need to read the old messages that were produced days or even months ago. With Pulsar, you can offload those messages to external storage. So instead of using our fast and expensive disk in the cluster nodes, we can rather leverage the use of third-party cloud storage systems, moving it into a most cost-effective storage tier. And this is transparent for the consumers. If you need to replay a topic, some messages will be read from the cloud storage and others will be read from the bookie, but the consumer doesn't see this. It's transparent. This offloading is facilitated by the segment architecture I presented, and this architecture allows older data segments to be offloaded seamlessly. So we've seen what happens when you lose a node. But what if you lose a whole region or a data center? That's where geo-replication steps in. Geo-replication provides disaster recovery. You have several clusters deployed in different regions or different data centers, and if you lose a region, you can recover from it. Pulsar can replicate the data to different regions automatically in a bi-directional way. And this is a built-in feature, so setting this up is basically about configuration. Now I'd like to introduce another very cool feature of Pulsar, multi-tenancy. Multi-tenancy allows different departments or teams within an organization to share a Pulsar cluster while keeping their data isolated. Multi-tenancy helps applications work in a shared environment by providing structure, security, and resource isolation. So the benefits include easier management, as you only need to operate a single cluster for multiple teams. Plus, sharing resources can lead to a significant reduction in the number of nodes in your infrastructure, which can save on cost. And this is not a hack or another layer on top of Pulsar. Pulsar is designed for that. This is a built-in feature. So now you could say, well, Julien, Pulsar has impressive features, but you know, in my company, I have an existing software ecosystem. I'm sending or consuming messages with Kafka and RabbitMQ. I have a bunch of applications, a bunch of microservices, and I can't rewrite all of them. I can't afford that. Well, I have good news for you. Pulsar has a high level of compatibility. Messaging and streaming involve clients and a broker, right? They communicate using a protocol. Pulsar provides its own binary protocol, but with the addition of protocol handlers, Pulsar becomes compatible with Kafka clients, RabbitMQ clients, and MQTT clients. So by leveraging your existing apps, you can avoid the need to rewrite everything and ensure a seamless migration path. To write client applications using the Pulsar native protocol and benefit from all features, you have many Pulsar clients libraries available. You will surely find one for your favorite language. Don't hesitate to check out hub.streamnative.io, where you'll find a wide ecosystem of connectors, libraries, protocol handlers, etc. When it comes to choosing a technology, open source is key, right? Some of the benefits of choosing an open source technology are sustainability, avoiding vendor locked-in, and community support. And Pulsar, of course, is open source. All these features I presented are available in open source. So if you download Pulsar, you'll have all of them. This is great because you don't depend on a specific vendor. You're free to call a vendor to provide a Pulsar as a service like StreamNative, or you can manage a Pulsar cluster by yourself. There is no vendor lock-in. Some data on the Pulsar open source community. There is more than 600 contributors to Pulsar, and there is more making contribution to the ecosystem surrounding around Pulsar. And you can discuss with the community on Slack. The number of Slack members reach 10,000, so it's so many people can help you. Additionally, there are now thousands of organizations using Pulsar. And it's worth mentioning that Pulsar has been in production for over 10 years now. This means that it's battle tested. It's proven to be robust and mature. So here is a quick recap. Pulsar is a unified messaging and streaming platform handling both patterns, both semantics at the same time, so you can have only one platform to manage. Pulsar is doing great at both scaling and being elastic, and provides 3 levels of elasticity. Pulsar ensures the durability of the data and can offload to external cheap and unlimited storage. Pulsar has geo-replication built in, which is great for disaster recovery. Pulsar is natively multi-tenant, Pulsar is compatible with your ecosystem, and all these great features are available as open source, so you have no vendor locked in. Alright, that's the end of my talk. I hope you enjoyed it. Feel free to scan this QR code to contact me and to get access to additional resources. Feel free to try out Pulsar by downloading it, by installing the operators, or by signing up for StreamNative Cloud. And if you have any questions, don't hesitate to reach out. Thank you very much. Bye.